Okay, good morning, maybe evening. Um, this video is just to explain this Dr. Ume's assignment, the Excel parts. I'm going to try to explain from the question. If you happen to already understand how to solve the question, you can just skip forward to the Excel parts where I would explain the formulas and how everything works. So, but let's quickly move on to the question. I think it's important to know how to solve it so that you can understand how to move on to the Excel. Now, um, I'm going to be very brief. I'm not solving anything, obviously. I'll just be showing you how this textbook did their answers. If you quickly read through the question, this is a simulation problem for an investment corporation, and there are really a few things that you need to note here. One is the fact that there are three factors in this question. You have the market demand, and then you have the profit per unit, otherwise written here as price minus cost per unit, and then you have the investment required. And then the question gave you the probability for each of these possible units. So for this particular investment corporation, the probability of them having an annual demand of 20,000 is actually 0.05. Probability of them having 25,000 is 0.1, like that to the end. So it is very unlikely for them to get 50,000 annual demand, but it is still possible. It has a probability of 0.05%. Same thing too with the profit per unit. That is the amount of money that they get per unit item that they are selling or that they are investing in, whatever. So for them to get 3 RS, they have a probability of 0.1%, of 1% really. Then for them to get 10 RS profit per unit or price minus cost per unit, it has a 1% probability. And then the investment required for them to get any of all these results here, they have 17, be 1.7 million and 22 million and then 2.5 million. And this is their probability all written out here. Now, the question now says, using this simulation process, repeat the trial 10 times and compute the return on investment for each of these factors. And then take note of the main question here, because it's really going to guide how you're going to go ahead and create your table. That is when you're solving now. So listen to the question. The question says compute the return on investment for each trial. Okay, so you're going to compute R for each trial for the 10 different trials, and then they said what is the most likely return, which return is the most likely to happen. Now, the question also gave us that this is the formula for R that we're going to solve. This is price minus cost, which is the profit, like I mentioned earlier, multiplied by number of units demanded all over investment. Now, this formula may look somehow, but this formula is actually um, return percentage. It's not really return as in the exact profit you are getting. Otherwise, I think that should have been minus investment. So it is in percentage multiplied by 100 is what is here. Okay, so quickly moving forward now, because we have three different factors, as I stated earlier. We have annual demand, price minus cost per unit, and we have investment required. Because we have three different factors here, we are going to draw three different tables for each of those factors. And in this textbook here, they have already solved it in table 19.26, 2.7, and 19.28. So let's just quickly look at the tables and how they solve it. These tables are pretty straightforward. The first two columns of the table is already given to us. We have the annual demand. We just listed out what they gave us in the question. The probability, we just listed out what they gave us in the question here. So this is where our solving now begins. Cumulative probability and random number interval. I need to emphasize here that this shouldn't be random number. This is random number interval. We have not just note that it's random number interval because you can see x to x, like something to something. So that's interval. So how do they do the cumulative probability? It is very simple. You just repeat the first one and then you add this to this. You have the next value here. So 0.05 plus 0.1, you have this value. this value plus this value, you get this one here. 0.35 plus 0.3, you get this value. 0.6 plus this, like that till the end. Then this column here also guides the random number interval. Some persons may want to do 100% cumulative probability as a different column, and that one is also straightforward. You multiply everything here by 100. In this case now, this would have been 5. That is, if you have another column here saying 100% cumulative probability, this would have been 5, this would have been 15, this would have been 35. Pretty straightforward. But even from here, you can move forward to random number interval, because just look at the way it is arranged. So for random number interval now, you start from 0 and you end one number less than this place. Like, you don't want to start, you don't want to end here. You want to end one number less. So in this case now, this is 0 to 4. And here, this ends with 15, right? So this should be 5. You now start from this one and end, minus one number. That's 5 to 14 in this case. And this case now should be 15 to 34. And then here, you're starting from where this one ends, 35 to 65, to 64 rather. Okay, so this one is 65 to 84, 85 to 94, 95 to 99. Then, under to emphasize something, one thing you should note is that your random number interval must start at 0 and end at 99. If your interval is reaching 100, there's a mistake somewhere. Same to do with cumulative probability, it must end at 1 on the dot. If it ends at something 0.99, if it is above 1, that there's a mistake somewhere. You need to go back and look at it, go back and correct it. Okay, so we're already done with the table for one of the variables, which is the annual demand, and as you can see, that's also pretty straightforward. Moving on to the next table, the price minus cost per unit, is also straightforward. Repeat the values given from the question here. Also repeat the probability, and then you're not adding the cumulative probability. Like I said, repeat this one right here, then add this to this. You're going to get this color, this value here. Add 0.3, sorry, add 0.3 to 0.4, you have 0.7. Then add 0.7 to this, you have 0.9, and then add 0.9 to this, you have 1.0 on the dot. Now, random number interval, remember, same thing. This ends with 10, so your value is going to be 0 to 9. Now after 9 is what? 10 now, so this should be 10 to 29. There is a mistake in this textbook if you observe. Can you see? So this is why it's really important for you to understand what you're doing. Here now, this is 0.3, 0.30. So there's a mistake here. This should be 10 to 29, because 29 is the number before 30, and here now should be 30, not 20. It should be 30 to 69. So they just made mistake in two places. It's a very small mistake. So 0 to 9, 10 to 29, 30 to 69, 70 to 89, and then 90 to 99. Remember, no 100. Okay, so that's it for this table. I hope that it is clear. Let's quickly move on to the next table. So the table for the third variable we have is the investment required, which is right here, and this one is just 3 inputs. We have 1.7 million, 20 million, and 2.5 million, and this is the probability for each of them. Like I said, first 2 columns is from the question. The cumulative probability, just input 0.25, add it to the next value of probability, and you have your next one. Everything should sum up to 1. And the random number, same thing, 0 to 24, 25 to 74, 75 to 99. All right, so that's that. This has been very simple so far. This is where the work actually begins. Now, the question asks us to impute 10 trials in our simulation, and then find the value for R for each of those trials. R is the return. So what the question is really asking us is, just imagine you have a given demand for a year and a given profit per unit for that year, and you invested X amount of money that particular year. How much is the profit you're going to get? So we are putting in random values. Remember, this is a simulation, so we're just trying to see what is likely to happen and what is not likely to happen. So I'm putting in random values 10 times to try and have a prediction of what we can say, oh, this is an expected return for next year, and this is the most realistic, highest return that we can possibly get. I hope that makes sense. So now, for those that may be wondering, okay, if we are trying to solve these types of question that this woman is giving, how do we know all the columns that we are going to impute in our table and even the headings for them? Let me just attempt to answer that. So many of these things are already given in the question, right? You can see the trial, this place now that you have trials is already given in the question. The question asks us to do 10 trials. In some different types of questions where they say um, you would have 10 people visiting the hospital, that's already the number of um, rows we're going to have in that table. Since there are 10 people visiting, those 10 people count as the simulation number, right? So you just write 10 people in that case. So for this one now, they said 10 trials. So we're having 1 to 10 listed here as the first column. Now, for the rest of them, they said we have 10, we have 3 variables, and each of those variables have their simulation now. So that's why you have this column right here. This random number for demand. This is the column. Let me go to my solution where I color coded it so it will make sense to my brain. All right, so we have this column for the trials. Then this column is for the random number that we generated. All right, this column is for the random number that we generated, and this is the simulated result based upon whatever we put in the random number. Now, this is the random number for profit, the second variable, and then this is the simulated profit. This is random number for investment, this is simulated investment, and this is the R, the return, using that formula that the question gave us. This column right here is the return. So, one thing I need to note is that from the question, we were asked to select random numbers by ourselves. If you observe, the question did not give random number. It's only the solution that just picks random numbers. What this means is that, let's assume we are doing this in an exam, for instance. We are the one that's going to pick random numbers that we're going to remember, your number is between 0 to 99. No? So you're the one that's going to pick random number. You're going to put in any of all these columns I'm selecting now. Let's say column cells. Any of all these cells I'm selecting now, you're not going to put random numbers there. All right. So, but let's just follow what we have in the table by in the solution in the textbook by using the random numbers they themselves picked. Okay, so that we can cross check to know if whether we are correct or not. And that's exactly what I did. So, um, so that means we already know how to pick how to solve this column. Since I've just mentioned now that it is a random number, just input random numbers, 10 different random numbers for the 10 different trials. Same thing for this place. They do not have to relate to each other. 10 different random numbers for this place and 10 different random numbers for this place. So like this now, it remains 4 columns for us to solve. Now, the simulated demand, this is also pretty straightforward. I think we were writing it with pen and paper. It's very, very straightforward. Before I now explain how we're going to do it in the Excel one. So if you observe, let me separate my screen and bring this. Okay. All right. So if you observe in this table, the first table for the variable, you can see here that from the random number we generated, this is 25. What we can see from this random number interval is that whenever a value falls between this 25 falls between 15 to 34. Can you see? We're in annual demand table now, but right here. And 25, which we selected here, which we selected as our random number for the first trial, falls between 15 to 34. So that means that our value is going to be 30,000. Can we see that? That means our value is going to be 30,000. Okay. And another thing, one thing you need to note is that this table that we wrote here. The reason why I'm writing 30 instead of 30,000 is I'm just assuming that you know what, let me even write that here. I'm just assuming that whatever value we put here is times 1,000. Okay, that's why I just wrote 30 here. That's the same thing that they did in our textbook. If you saw it, let's go here now. Look at the textbook. They put 1,000. So instead of them just writing plenty zeros there, 30,000, just put times 1,000 there. Okay, so that's by the way. So I hope that's clear. Now, 25, like I said, falls between 15 to 34, which is equal to the annual demand of 30,000. So that way we have 30,000 here. Same thing to 57. 57 falls between what? 35 and 64. You can see it here, 35 and 64. So that's why we have 35,000 as an annual demand. 60 here falls between um where is it, falls between 35 and 64. That's why we have 35,000 as our annual demand. Same thing for everything right here. Once you look at the random number you picked for this column, you come to your table which you solved earlier, and this is why I said I wanted to explain how to solve it first before I go into the Excel. So you come to your table here and say, okay, let me pick the corresponding annual demand from the random number interval. All right, so I hope that is clear, because this is exact same process we're going to use for the remaining tables. Then we're solving by hand. We're just going to come to this random number profit we chose here. This one I color coded with ash, and then you say, okay, for 19, I can see 19 right here. 19 falls between 10 to 29. Remember, this is supposed to be 10 to 29, and what do we have as our profit is 5. So we choose 5 here. 7 happens to fall between 0 to 9. That's why we have 3 here. You can see 90 happens to fall between 90 to 99. That's why we have 10 right here. See 10 here. 90 to 99. This is 10 here. Okay, so that's how we did everything to the end. Now, if we go to the next column, random number for investment, let me open that other table. Okay, so random number for investment, this is the table for that one here. And we can also see it's exactly the same thing. When we pick 18, 18 falls between 0 to 24, and that's why we have 17,050. Remember, it's also multiplied by 1,000. All right, so that's all very, very, very clear. And if you're solving by hand, you are already done. Like, you're already done. Then the R now, okay, I think the R is what is left. Look at the formula for R in this place. Please look at where my mouse is, right here. Formula for R is demand times profits per unit all over investment times 100. You can see it is in percentage now. Look, please see where my mouse is in case you're getting lost. It's in percentage. Demand times profit per unit all over investment multiplied by 100. That's exactly what we did here. So basically, what that is let me go back to my Excel sheet. So basically, it means for this particular cell right here, it means for to get R for the first trial, we did what? We did this value here, the simulated demand, multiplied by the simulated profits, all right, all over the simulated investment times 100. I hope that makes sense. So this times this all over this times 100. Okay, so this value, simulated demand, times this simulated profits all over this times 100. That's exactly how we got 8.25 here. If you punch that into your calculator, you're going to get 8.57, which is the value I got here. And if you can look at the formula we have here, or let me just click this so that the formula is going to show. You can see the formula I used here. I used multiply because we are doing percentage now. So this everything here multiplied by 100. I'm solving the end first. This is algebra now, so we know how to do our value. So multiply everything right here by 100, and then we're not talking about the top now. So the top, multiply C2, this cell, This is C2 cell. You can see it's highlighted. Multiply this cell by this cell and then divide. This is the divide symbol. Divide it by simulated investments. Then multiply everything by 100. And that's exactly how I did that here. So in Excel, you don't need to repeat all of this. You don't need to come here now, copy, paste, then you now start typing. You now start typing, okay, for this one, this should be C3 and this should be E3. Be changing the values. No. In Excel, you can just take this button over here and drag everything down, and the formula is going to repeat itself automatically to everything we have. Like the formula is going to respect itself and just repeat. You can see if I take this and delete now, let me delete this, and there's nothing there. I'm not afraid because I can just drag it down, and it automatically knows that, okay, for the second cell is this place I'm talking about, not this place. So it knows is C3 I'm talking about, not C2, and it would solve it. So quickly moving forward, the the formula for R is the most straightforward. Is this other part now that is a little bit tricky. First of all, let me explain why we're even doing this. Because the woman said that what she wants is a case where, remember I told you that these values in this column, or this column I made ash, all of them are random numbers that can be generated by anybody. If all of us are solving this on our own now, we can use any random value. So what she's trying to say now is that she wants a way where any, like if she comes now and edits our table and puts in a random value by herself, our result is also going to respect that random value, and all the simulated values is also going to respect it. For instance, I have 25 here. If I change this 25 to 60, it's supposed to affect, can you see it affected the simulated demand? It also affected the R. That shows that the table is dynamic. If I change this 58 here now to 1, it affected the simulated demand, it also affected the R. Please let me do Control Z, Control Z, I beg. All right, so same thing too. If you change the value of any of all these random numbers, let me say I change this 7 to 99, you can see it affected the simulated profit, it also affected the simulated return. So now, how did I do? I've already explained how I did R. How did I do this one for the color-coded ones, the ones that are ash? It's very simple. In the simulated demand place, I use an Excel function called VLOOKUP. So VLOOKUP is a formula that has four different variables. I say variables. It has four different things that you need to input. The first part of the VLOOKUP formula is the search function. That is this B2 here. It means what you want to use as a reference to search in your formula, your VLOOKUP formula. I'm not going to go too deep in that. I just want to explain what you have here. So the first value that you have in your VLOOKUP function is the search function. In this case, I want my VLOOKUP to use the cell B2, that is this place here, um, as a search function. That is what it should be looking for. Where should it look for that in? You should look for it in an array, which is the next value here. So the next value in your VLOOKUP is an array. All the values in your VLOOKUP formula is separated by comma. Okay. So first value in your VLOOKUP formula is search function. Second value is the array, and the third value is the index. I'll explain all these things. Then the fourth value is either true or false. So I think let me just quickly use this example that we have here to explain. Oh, I'm not online. I'm online. Okay, so now what this means now, this array, I had to write it by hand, and it's just basically what I took from the question that I imputed here. So if you remember that table we had in our question, I hope that this now explains going to be clear, Sha. If you remember that table we had in our question, we said what? Let me share my screen. Let me separate my screen. So look at the table we had in our question now. You can see here that 0 to 4 gave you a value of 20. That is 20,000 now. 0 to 4 give you a value of 20,000. And 5 to 14 give you a value of 25,000. I just impute here that look at this array now. You have 0 to infinity should give you a value of 20,000 of 20. Okay, and then 5, because I've used semicolon here to start a new value 5, it means that this 0 here is already restricted to 4. Okay, that's just basically how it works. So before it was 0 to infinity gives you a value of 20. Then I now use semicolon. I'm trying to make an array here. It's an array I'm writing, but just with curly braces, comma, and semicolon. Okay, so 0 to 4 gives you a value of 20. 5 to infinity gives you a value of 25. But because I started the next part of the array with 15, it has automatically locked up this 5 to stop at 14. I hope that makes sense. So 15 to infinity gives you a value of 30. 35 to infinity gives you a value of 35. 65 to infinity gives you a value of 40. That's the end. 95 to infinity gives you a value of 50, and then I close up the brackets. All right. Um, what you would observe now is that even though, remember when I said that our random numbers that we're picking for ourselves should stop at 99, but if I come here now and I impute this thing as 125, for instance, it is still going to give a value because of the way the VLOOKUP formula works. It is taken to infinity. All right, so as long as I did not put any constraints at the end, it will say, okay, you said 95 to infinity um should give you 50, and that's why it keeps going ahead. So back to the formula. Then this index of 2 here just simply means that, okay, you go 2 squares to the right from where you're coming from, and um impute your results there and search for it there. And then true just simply means do not make it an exact match. All right, don't make it an exact match. You don't need to understand like the entire intricacies of VLOOKUP. It's not that important. We're not going to use VLOOKUP again. Do you understand? So if you really want to know exactly how VLOOKUP works, I can send you the link that was able to explain this thing very well to me. But this is just really what you need to know to solve this part. Just put 2 and use true in your own. If you use false, which is the other value that you can use instead of true here, it will try to make sure that it is an exact match. Let me show you an example of when it is an exact match. I think is in displays. I think displays now it is an exact match because we said what? We said it should search for D4 in our array, and if 90, and we said what? 90 to infinity should be equal to 10. Okay, so in this case, exactly what we have in our random number is 90. So if you make this place false and you press enter, it still gives you your result. But if you put false in any other one, it won't give you your results because you can see NA. The reason is that you have 19 here, but 19 doesn't happen to appear in any of these your arrays here. So when we just say true, we're just trying to say, guy, you don't have to be exactly what I wrote. You don't have to be exactly what I wrote here. Just as long as you fall within that range of, what's the range that this one falls in now? It falls in the range of 10 to 19. So thank you. As long as you fall in that range of 10 to 19, guy, just give me my 5. Just give me 5 as the output. You don't have to be exactly what is written inside this array. That's the meaning of the true. So I hope everything is clear. I did my best to explain this entire thing. If you really want to learn the intricacies of VLOOKUP, I can send you the link that explains to me. That's what I'm trying to load now. The network is not going. I can also show you this sheet so you can play around with it. So that's it. Thank you very much and see you later. Good luck in your exams.